Hello friends, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is the lecture of IR spectra and lecture number 29, in which I will explain you application of IR spectra, particularly NH stretching and bending. So the groups which contain NH bond are amines. So let us discuss first of all amines. First of all, we will take primary amines, in which there will be NH2 group. That means there are two NH bonds in primary amine, and if both these bonds stretch in this direction, then it is called symmetric stretching, and if there is no hydrogen bond, then we consider this as free symmetric stretching, and the bands appear nearly 3300 centimeter inverse, which will be normally weak and sharp. Along with this, there will be asymmetric stretching also, like this, and if there is no hydrogen bond, again it is called free asymmetric stretching, and that band will appear at nearly 3500 centimeter inverse, which is again weak and sharp band. So these two bands will look like this. They are always associated with each other. So this is nearly 3500 centimeter inverse because of asymmetric stretching of NH bond, and this is at nearly 3300 centimeter inverse, and this is due to symmetric stretching of NH bond. Okay, the associated NH bonds are weaker and frequently sharper than corresponding OH bonds. Okay, bands, sorry. So these bands are weaker and sharper than corresponding OH bands. Remember, OH bands also having signals or bands in this range only. So we'll have to be very careful when we decide which group is present in a given compound. Next is secondary amine. In secondary amine, you will find only one NH bond, and that is why only one band appear at 3500 to 3300, or maybe up to 3000. We can consider up to 3000 centimeter inverse. In case of tertiary amine, there is no hydrogen attached to nitrogen, all are carbon, and therefore NH band is absent. If we see aromatic amines, then this absorb at slightly higher frequency than aliphatic amines. Okay. Next is NH bending. So next we'll see NH bending. In primary amine, NH scissoring appear at 1650 to 1580 centimeter inverse, and this band is medium to strong. NH bending in secondary amine, particularly aromatic amine, at 1515 centimeter inverse. If sample is liquid, so liquid samples of primary and secondary amines display medium to strong, broad absorption in the range of 909 to 666 centimeter inverse region of spectrum, and that is due to wagging. Okay, so this way you will see the bands NH bending as well as NH stretching in amines. Now we will see C single bond N stretching in amines. You know, there will be always C single bond N bond in amines. So C single bond N stretching in case of primary, secondary, tertiary amines will be between 1250 to 1020 centimeter inverse, and these bands are medium or weak. In case of aromatic amine, C single bond N stretching for primary aromatic amine is between 1342 to 1266 centimeter inverse, and this is having little bit higher value than this because of force constant for aromatic amine will be higher. Now we will see another functional group, amide. Amide is having RCONH2 group, that means there is NH bond also. This is called primary amide. So here you will observe two NH stretching bands. Depends of the preparation of sample. Now in case of solution, we will observe two bands, one at nearly 3520 centimeter inverse and another band at nearly 3400 centimeter inverse. In case of solid state, if sample is solid, then we will observe nearly 3350 centimeter inverse and second band at nearly 3180 centimeter inverse. Okay. Now in amide we also observe NH bending. So it is at 1655 to 1620 centimeter inverse in case of solid, and at 1620 to 1590 centimeter inverse in dilute solution. At 800 to 666 centimeter inverse, we observe NH wagging, which is broad or medium. Okay. C single bond N stretching in case of amide, it will be at nearly 1400 centimeter inverse. And as C's double bond O group is also present in amide, so C double bond O stretching is also observed at nearly 1650 centimeter inverse here because of C double bond O. Okay. Now there is another group called nitrile. That is C triple bond N. If aliphatic nitrile, that means R will be alkyl chain, RC triple bond N, then at 2260 to 2240 centimeter inverse. And in case of aromatic nitrile, that is ARC triple bond N, we will observe 2240 to 20 centimeter inverse. This is because of conjugation effect. And there are some other groups also, N triple bond C, N double bond C double bond O, then N double bond C double bond S, C double bond N double bond O. Here you will observe at 2273 to 2000 centimeter inverse. Okay. In case of imine, imine is having C double bond N, and C double bond N will be observed at 1689 to 1470 centimeter inverse. Okay, so these are the functional groups in which you will find amines and amide also. Now we'll take certain examples. For example, suppose we take aniline. You know, aniline means there is benzene and there will be NH2 group over here. So this is called aniline. So you observe certain groups or certain bands here. The first band will be at 3442 and that is due to NH stretching, and that shows primary amine. Well, another band appear which is very close to this 3360, again NH stretching, and these two bands appear close to each other, so we consider them as doublet. Okay, here third band will be at 3045. This is because of CH stretching, and as the value is greater than 3000, it is due to aromatic CH stretching, sp2 hybridized. Next band appear at 1620 centimeter inverse. It is due to NH scissoring. Next band will be at 1280 centimeter inverse. It is because of C single bond N stretching. And the last band will be at 764. This is due to NH wagging, and that's considered primary amine. So this way we can see aniline, and here aniline is having this type of bands appear, and this way you can identify the given compound. Now next compound will be isobutyl amide. Here you will observe 3350 and 3170. These two, one is due to asymmetric NH stretching and another is due to symmetric NH stretching, and these two are doublets. And here you can see broadband, if appear is a broadband, then because of hydrogen bond. So hydrogen bond is also present in this condition, we can say like that. Second band is at 2960, that is due to CS stretching, and again it is aliphatic because it is less than 3000. Okay, third one is at 1640 centimeter inverse. It is because of C double bond O stretching, and again that can be because of NH band also. So these two will overlap and form a broad band. Next will be at 1425 centimeter inverse. It is because of C single bond N stretching, and the last one appear at 700 to 600 NH, that will be out of plane wagging. So this way we come to know which compound is present from the given data. Thank you so much.